And welcome, viewers. Thanks for tuning into the Smash News Network's Busted Damon News. Today we'll be talking about filaments, solar flares, and some incoming coronal mass ejections. So we forecasted 3 stealth ones on the way. The next 3 are obvious. We'll cover it. Lots of filaments. We even named one of them after Michael Jordan. We'll talk more about that in a moment as well. Here are the past 24 hours. This is just the past 2.5 hours. From the GOES 16 SUVI. Here's the SDO for a full 24-hour run. If you look to the left as well as below the Earth scale that we've shown there in that imagery, you will see 2 absolutely massive filaments, especially the one to the south of the Earth scale. That is one of the largest filaments in over 6 years. So that is a really big and dense plasma filament. Fingers crossed that it becomes a coronal mass ejection at some point. There's a close-up of that, the Michael Jordan solar filament. That massive filament named after one of the world's most massive competitors of all time. Fun fact about Michael Jordan, did you know that he pretty much must compete about everything? Anyway, here's a great one in the Northeast. If you want to name that one after your friends, foes, or even yourself, join us over on Twitter. At SmashOMash, just follow the hashtag Name That Filament. Name That Filament, America's favorite pastime, or soon to be, as the emphasis on private space flight isn't going away, and hence the emphasis on legitimate content about space weather not going away either. Sunspot 3712 is of honorable mention, as it is our TMAS. The most active sunspot. So there it is. It's not changed a whole lot since yesterday. There still is a very high likelihood of an X-class solar flare. So some M-class events mixed in there. And again, 3, count them, 3 coronal mass ejections now on the way. 2 of which are likely to produce major geomagnetic storm conditions. So that's always nice. Again, we'll talk more about the timeline in a moment. And if you're new to the channel, don't forget to press the like button and especially the subscribe button. Press share, tell your friends and foes about the channel. Be a hit at parties by explaining to people how space weather works. And we'll have to pick up the speed a little bit on this video because there's a lot of stuff to cover today. So if there's anything that we just gloss over, just hit us up in the comments and we'll answer it, or perhaps our viewers will. 10.7 centimeter radial flux now at 167 solar flux units, a slight dip from yesterday. There's the past 1 year depicted by that black line at solon.info. NOAA is not forecasting the impacts of the CMEs. So again, there are 3 on the way. Actually, there are 4 on the way because there's one to arrive sometime late in the day tomorrow, possibly early in the day on Wednesday. Yeah, Wednesday. But NOAA's not picking them up yet, and neither is ESA. So here's NOAA's Enlil spiral. As you can see, no space weather in the forecast there by NOAA. And here is ESA's Enlil spiral, same deal there. No space weather really showing up in the forecasts. Again, we'll get to that momentarily here. The KP index, an average of global geomagnetism, is currently at 3. KP3 is the current situation. It is geomagnetically calm. By the way, the second of the 3 stealthy CME impacts arrived right when we said it would. Earlier today, it was around 1400 Universal Time. Anyway, we'll get to it. There it is. Here's the impact. 1400 Universal Time is when that showed up. You can see here a change in the plasma temperature, which is this bottom green line, change in the solar wind velocity, as well as the density. It was not accompanied by big-time magnetic fields, but enough to push the KP index up to 3. So those are the readings from ACE. They are the most current. Let's get that on something. Come on, display a number. There's the most recent from ACE. We'll call out the Discover's numbers, which experienced that CME about the same time, just a little bit later than the ACE. So, current conditions from Discover are about 8.25 protons per cubic centimeter with solar wind density, solar wind velocity here, just over 450 kilometers per second. So there are our GOES magnetometers there, the Agos 18 doing a little bit of maneuvering. The arcjet moment represents plasma created by its thrusters as it maintains its geosynchronous near equatorial orbit. And let's move on to the magnetism of the heliosphere. And Earth looks like it is snapped into a South Pole magnetic sector. So there's the last image. South Pole magnetic sector. We have a quite well-defined coronal hole in the northern polar region. I don't think it's going to produce any high-speed solar winds here at Earth. It's too far north, but we'll have to see what happens there. We'll get to coronal holes next. First, our line-of-sight field plot depicting the photosphere magnetism in gray, polar fields in green and red for north and south respectively, and the solar B field in blue. The B field being the field that goes through the magnet, that magnet being the sun. Here's our coronal hole line-of-sight field plot. And yeah, well-defined coronal hole there at the north polar region. As our channel depicts the solar polar field reversal process on the regs. It's what we do. So here are coronal holes. There are the past 48 hours for you. North Pole coronal hole rotating out there in the west. South Pole oriented coronal hole rotating in here near the polar region. That brings us to sunspots. Sunspot number here dropping below 150. Current sunspot number is about 138. 138 sunspots is the current number according to Rob, the Royal Observatory of Belgium. Here's our flare probability monitor and scoreboard, and as you can see, the computer's still calculating a 61% chance, over a 60% chance of an X-class solar flare from sunspot 3712. So that's pretty good. Fingers crossed for some more action when it comes to space weather. If you're spooked of solar flares, you probably shouldn't be. It's not really very likely to harm you in any way. So yeah, sunspot 3712 remains the most likely place to see a large flare. And let's move on to sunspots here. So here's the SDO's imagery. And that's not too bad. Let's get in a little bit, well, the magnetogram first. So not a lot of changes in the past 24 hours in sunspot 3712. It looks like it's degraded a little bit in its magnetic complexity. I'm not sure if the likelihood of an X-class flare is still 60%, but it's still up there. So now, by the way, this was an oversight on my part. I rotated the field of view, but I forgot to move the frame over a little bit. So that's an unrecoverable mistake on my part. Sorry about that, viewers. We make these videos in a narrow time frame, so we're unable to go back and change those once everything's ready to go. So there's the continuum. Still a great close-up of sunspot 3712, even though we're missing the easternmost umbre a little bit. Again, sorry about that. And let's move on to energetic particles and flares. No spikes in the proton flux. It remains at baseline levels. So no polar radial blackouts, etc. And we had an M-class flare while we produced the show today. That was an M1.3. We also had an M1.5 and an M1.5. So that one looks bigger. It must be an optical illusion, folks. So yeah, 3 M-class flares in the past 24 hours. Likely all from sunspot 3712. So here is the view in SDO 131 angstroms. You should be able to count 3 flares, although the last one might not show up there because it was so close to when we produced the video. A little closer view of the equator. And don't worry, we're going to zoom way in. We've got some fantastic footage today, as you may have come to expect from the channel. Lo, the past 6 years of daily space weather coverage. So there is that close-up view, sunspot 3712. It remains the T-mass. It remains T-mass, the most active sunspot. We'll also show it in 94 angstroms. These are 24-hour videos from SDO at 30 frames per second. 94 angstroms. All of the AIA instruments are depicting extreme ultraviolet radiation. UV light, the high energy type. And before we get to filaments and CMEs and so forth, well, let's show filaments first. We're going to come back to filaments here at the end of the video. There it is in, that's 304 plus 193 angstroms. There's the equatorial zoom. Yowzer. So plenty of features to cover. Plenty of features indeed. By the way, remember folks, only 3 days until summer, which makes this the 6 brightest days of the year for the Northern Hemisphere. And what makes summer summer? Well, what makes summer summer is that the sun is at its highest point in the Northern Hemisphere, or if you're in the Southern Hemisphere, the June solstice is when the sun's at its lowest point. In other words, the winter solstice. Here's your solar system forecast. This is where things are today. There's where they'll be on the 24th. We will have a gibbous waning moon as full moon approaches. Here's a quick view of a star chart. Feel free to pause the video on this frame if you want to make your own. Skyandtelescope.org is a great spot to go. It's where we get our star charts from. And here's our astronomy photo of the day, which is a fantastic oxygen nebula within a hydrogen emission nebula. So you got a very hot blue star there emitting a bunch of oxygen with this background of red hydrogen. So different spectra shown there. The red is hydrogen, the blue is oxygen, and that star producing some metals. As in cosmology, everything to the right on the periodic table of helium is considered to be a metal. So that's a metal star right there, and it's producing this awesome squid-like nebula. Just a great view of that there from Alex Lind Astrophoto. Let's run that down one more time. Yowzers, that is pretty sweet. We'll give you the slow pan. How you like them apples? So those, of course, those shells of oxygen, they're giving you some insight into what that star's most recent extreme emission events look like. Some stellar novae going on there. Seeding the local area with oxygen. Not half bad. Just spectacular imagery. apod.nasa.gov is the astronomy photo of the day where we derived it. There is the page. Cheers. So CMEs, 3 more on the way. I have no reason to think that none of those appear to be on the far side. So those are all earthly directed CMEs coming right out of the center of the solar disk. Expect them to start arriving early in the day on the 20th. Early in the day on the 20th. They look like they're fairly high speed. They might even show up late in the day on the 19th. So we're going to have CMEs just coming in. That's no less than 3 of them. So there's LASCO C2 on the left and C3 on the right. We'll play those through sort of individually here. And it's been a busy day for coronal mass ejections. So multiple events there. Unfortunately, we've got some missing data from those. And yeah, but there is plenty for forecasting. We'll also show stereo A. Stereo A is located where that red dot is. That red dot right there. That's where stereo A is located. And here is what's been seen this morning, starting this morning at 0 dark 23 from stereo A. So you'll see 3 CMEs, 2 of them are in rapid succession. So the first one will be out of the southeast somewhat. It is earthly directed. So there's one earthly directed one, partial halo there. And then 2 in succession right out of the center of the solar disk. Let me rock that back for you here. So one first starts to appear around 8:30 universal time. You can see that partial halo. And then 2 more starting right around 11 o'clock. 1, 2. So just fantastic. Space weather on the way. Showing up most likely late in the day on the 19th. From these 3. Of course, there's another one from yesterday's daily space weather video as well. That was another more stealthy coronal mass ejection. And let's cut to our custom coronagraphs. So here we synced together SDO along with the coronagraphs there from LASCO, the SOHO LASCO spacecraft. And really it's not doing that great of a job modeling the second bits, but they're there. So we'll show you the origination spot from those. They do not appear to be far side events, by the way. So the first one was the most mysterious. However, up here center disk and down here center disk, you'll see two brightening there. Those are hider flares as plasma splashes back down toward the chromosphere. Those are the source of at least the second two CMEs. So the first one may miss Earth. I think all three will hit Earth, but the first one might miss. The second two are pretty much straight-on hits. So don't be surprised to see a KP7 plus from at least one of those events. It all depends on the magnetic fields. That's the most important feature in my opinion. I mean, plasma density and speed and temperature do matter, but the magnetic fields can be extreme. So anyway, let's move on to filaments next. Filaments, wherefore art thou filaments? Because magnetic fields are helping them defy solar gravity, which is massive. Like that Michael Jordan filament. Again, if you want to follow us over on Twitter, x.com/smashomash, follow the hashtag #NameThatFilament. The one in the northeast has not been named yet. So there is the view from Cerro Tololo. You can see that huge prominence there turning in just great imagery as always. Filaments. They're important. So here's 284 angstroms from the GOES 16 SUVI. That's the past couple of hours. Interestingly enough, 284 angstroms is another ionized species, and that one's not covered by the SDO, so I figured I would show it for a change. 284 angstroms there from the GOES 16 SUVI. It's mainly good at showing active regions. It does show prominences pretty well, as you can see in the northeast, which would be your screen upper left. Bonus features are next, and we do have some satellite charging hazards. Some low-energy electrons there building up on the outside of spacecraft, known as surface charging hazards there over the Southeast Asia portion of the planet. GOES electron flux here remains low, and it's going to stay low for days because with so many CMEs on the way, and it looks like NOAA agrees with that. That's NOAA's forecast model for the electron flux, which is measured at the F-layer of the ionosphere. So that's where that is, 300 kilometers of altitude. Okay, and there is the F-layer. It's pretty chill, but there has been some space weather rolling in, so we're expecting some low-frequency anomalies here, which we will show you next on the Anomalygram. That's depicting raw megahertz, millions of vibrations per second, as the diffuse gas shakes rapidly at 300 kilometers of altitude. That's space. That's the upper portion of the bridge between Earth and space. You could arguably state that space starts around 80 kilometers of altitude, where the ionosphere begins, the D layer of the ionosphere. You know, when most of the particles are ionized, you could make the argument that that's space. I mean, space weather occurs above Earth's neutral atmosphere, so it's a pretty good argument to make when it comes to space weather. Of course, that's why we don't cover the Schumann, because the Schumann occurs in between the D layer of the ionosphere and the ground level. So anyway, that's the ionosphere in Anomalygram. South Atlantic anomaly is still around the coastline of South America, around the 45 degrees west longitude line. As you can see on the map very clearly, South Atlantic anomaly has moved to the coast at the 45 degrees west longitude line. It's very obvious in the maps. We'll also show the Global Ionosphere Nowcast to help out you radio and GPS users. I'm a regular user of GPS, so I always like to know where the errors are most likely to happen, as it can have significant effects on those of us navigating using GPS. Many times I find myself on the bike and having no idea where I'm located. So it always helps to know if you're going to have massive GPS errors. Turn on Wi-Fi location accuracy, perhaps to improve those features. So We do have some magnetic complexity up here. It's not really too exciting. Not really. That's barely a beta gamma class sunspot. This one down here, oh yeah, that is still quite magnetically complex. So that's a good thing. There it is, up close and personal. Sunspot 3712. Here's the full disk view. And here is our final couple of frames. Yeah, there we go. Filaments. Keep an eye on them. And when I say eye on, the pun is intentional. It's time to close this thing out, but thanks for tuning in regardless. Don't forget to press the like button. And if you're new to the channel, don't forget to press subscribe. We'll see you soon here at the Smash News Network, least busted name in news. I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.